we are going to start with the topic that's acid bases. So in this class, I will be just doing what are acids, what are the categories of acids, and the physical and the chemical properties of an acid. So first of all, we need to understand if we categorize the substances, so we categorize the substances, there is one categorization in which we categorize them as acid and as bases. This is one category, this is a second category, and this is a third category. The category of acid and bases, they are chemically opposite to each other. So we say that the acid in nature, they are chemically opposite to an alkali. They are chemical opposite of bases or alkalis, right? So I'll make you understand what is the basic difference between a base and an alkali in the next video. Right now, our focus is only on acids. Okay. Generally, we have seen a lot of acids around us, right? So in the lab, we can see the acid like dilute nitric acid, like hydrochloric acid, like sulfuric acid. And around us in nature, we see the acids like, for example, we have the vinegar, right? That is basically your ethanoic acid. In vinegar, we have an acid which is known as ethanoic acid. Similarly, in milk, we have an acid. In the milk, we have the acid present. We call it lactic acid. Similarly, we have the acid in apples or pears. They have an acid which is known as malic acid. So acid is a category which is present in is around us, right? So acids, we say they are present in nature in the food stuff, but we have a category of an acid which are very concentrated, and those concentrated acids are basically very corrosive in nature. That means if they fall on a hand or on a clothes or on a skin anywhere, they can make hole through and through. आप यहाँ पर देख सकते हैं कि यहाँ पर here the this has this chemical, this acid, when it has fallen on this cloth, this has burnt out the cloth. So that is a characteristic of the concentrated acids, right? So all acids are not concentrated. We'll be talking about the different categories which are going to give this kind of an effect, and which are the acids which are present in the food stuff. So these are basically two different categories, but yes, they belong to acids only. Moving ahead. So before we move on to the properties of an acid, let's talk about what exactly are acids. What are the substances which are known an acid? Unme kya cheez hoti hai? Why they are called acids? So this is a definition for an acid. The acids are those substances which give hydrogen ion in an aqueous solution when they're dissolved in water. So all those substances which gives you H positive ion in an aqueous solution when they're dissolved in water, so those chemicals are basically known as acids. So if the examiner asks you in your CI exams that how will you define an acid? What are acids? So you say that acids are the substances which give hydrogen ion when they dissolve in acid. So for a substance to behave like an acid, they need to have H positive, and they need water. In the presence of water, this H positive ion is going to act like an acid. So for an acid to behave like an acid, right? So we can say that acidity, if a substance which need to act as an acid, for an acidity, we surely needs water. We surely needs water, right? तो दैट इज अ मैंडेटरी फैक्ट कि अगर आपके पास H पॉजिटिव आयंस हैं, लेकिन अगर वो वाटर में डिसॉल्व नहीं है, ठीक है, वो सॉलिड फॉर्म में है, या इफ दे आर बॉन्डेड विद सम अदर केमिकल, इफ वी टॉक अबाउट हाइड्रोजन क्लोराइड गैस, राइट, इट्स अ मॉलिक्यूल. Until and unless this hydrogen chloride gas is dissolved in water and you have hydrogen ion in an aqueous solution, this particular part, then only this chemical is going to act as an acid. So both the things are essential. We require H positive ion and the H positive ion need to be dissolved in water, then only this particular substance is going to turn blue litmus red, and it is going to show you the acidic property. So both the things are essential, right? So that is basically the definition. We have a lot of acids which are present in the solid form, but they do not give the property. Like for example, if you talk about the hydrogen chloride gas, the hydrogen chloride gas will not turn, well, is not going to give you all the property until unless you're going to dissolve this in water, right? So that is the definition. All acids contain hydrogen, but not all substance with the hydrogen contains are basically acids, because what is lacking, what is missing, it's a water is missing. So you require H positive ion as well as you require water, so that they behave like an acid. The hydrogen ion produced are responsible for the properties that we have already talked about. Okay, for an acid to behave like an acid, you require H positive ions, right? So here I'm writing some of the examples of an acid where I'll be showing you that they do have H positive ion present in them. So the first example is the formula for hydrochloric acid. This is known as hydrochloric acid, right? And we need to have this, this has H positive ion present in it. It has the H positive ion and it is dissolved in aqueous solution, water. Then only these two things are going to contribute, they are going to make this particular substance as an acid. Is this much clear? All right, moving to the second example of an acid. The second example of an acid, we have sulfuric acid. The second acid is basically is your H2SO4. That is a formula for sulfuric acid. And this acid will again behave like an acid if it is dissolved in water. So you have H positive ion in aqueous solution. The next example is your nitric acid. So nitric acid is going to be HNO3, and it is going to have the H positive ion need to be dissolved in water to make it behave like a nitric acid. Apart from that, we have CH3COH. This is known as ethanoic acid. This, which is in a dilute form, is basically known as vinegar. This is again in the aqueous form. Here, the H positive ion, which is going to behave as an acid, is this one. This H positive ion in an aqueous solution is going to behave like an ethanoic acid. Apart from that, we have multiple organic acids. And as I gave you the examples of the malic acid, the lactic acid, which are part of the foodstuff, they also contain H positive ion in an aqueous solution. So these are some of the examples: hydrochloric acid, sulfuric acid, nitric acid, ethanoic acid, which will be using in multiple reactions in the chemistry, in O-levels chemistry. This slide again quotes some of the main acids which we will be dealing with. Number one, hydrochloric acid, sulfuric acid, nitric acid, ethanoic acid. And yes, we need to know their formula as well. So the first definition we have done for an acid was basically these are the substances which give you, that was the first definition. All right, so this was the first definition, that the substances gives which gives H positive ion in an aqueous solution, they are known as acids. Fine. So this was the first definition. Now recently in your syllabus, the syllabus has been changed for 2023, or up नए syllabus के accordingly they have added another definition, and this definition is on the basis of another scientist, and this scientist has explained it on the basis of proton. Now when we talk about the hydrogen has got one as an atomic number and one as a proton number. So that means its number of protons are basically 1. And this is an atomic number, right? So its number of electron, because it's an atom, is going to be 1. And the number of neutrons are 0. So we need to understand, we need to know that the hydrogen, this is basically your atomic mass. This is atomic mass. So atomic mass is a sum of protons and neutrons. But if it is just one, that means the proton तो for sure आपका one है, लेकिन इसमें न्यूट्रॉन जीरो है. तो मैं यहाँ पर एक और एडिशनल चीज बताती चलूं कि हाइड्रोजन इज द ओनली एलिमेंट जिसका न्यूट्रॉन जो होता है वो जीरो होता है. ये आपसे एमसीक्यूज में पूछा जाता है कि विच इज एन एलिमेंट, इज देयर इज पॉसिबिलिटी कि कोई एलिमेंट ऐसा है कि जिसमें न्यूट्रॉन प्रेजेंट ही नहीं है. सो यस, वी नीड टू अंडरस्टैंड दैट देयर इज ओनली वन एलिमेंट इन द periodic table, that is basically hydrogen. तो हाइड्रोजन जो होता है, in the case of a hydrogen, they have one electron and one proton because they're talking about an hydrogen atom. और उसका मास और नंबर सेम है, तो इसका मतलब उसके पास न्यूट्रॉन नहीं है. सो हाइड्रोजन इज द ओनली एटम व्हिच हैज जीरो न्यूट्रॉन इन इट. अगर फॉर एग्जाम्पल मैं इसका हाइड्रोजन में से इलेक्ट्रॉन को रिमूव कर दूं, तो अगर मैं इसको रिमूव कर दूंगी तो क्या होगा, हाइड्रोजन विल बी फॉर्मिंग अ पॉजिटिव चार्ज एंड इट इज विदाउट द इलेक्ट्रॉन. एक ही प्रोटॉन है और वो प्रोटॉन इसके न्यूक्लियस में जस्ट वन प्रोटॉन एंड इट डजंट हैव एनी न्यूट्रॉन आल्सो. सो this hydrogen ion which have just a proton, no electron and no neutron, we can also generally call it a proton. तो एग्जाम दो साइंटिस्ट जो है, जो साइंटिस्ट जिसका नाम है ब्रॉन्स्टेड लाउरी, ठीक है, दिस देयर वाज अनदर साइंटिस्ट जिनका नाम है ब्राउनस्टेड लाउरी. सो ही गेव यू अनदर डेफिनेशन ऑन द बेसिस ऑफ प्रोटॉन. सो प्रोटॉन इज व्हाट, प्रोटॉन इज नथिंग बट द हाइड्रोजन आयन. तो उन्होंने कहा कि जो सब्सटेंस, the substances which are proton which donates proton, right, which donate proton, that means agar mere paas, if I have an HCl hydrochloric acid, H positive isme hoga or I'll be having H negative. When it is going to combine with an alkali, so what will happen, alkali are chemical opposite of an acid. What will happen here, the hydrogen ion will be replaced or be substituted, it will be replace the acid, is going to give away its hydrogen ion in order to form a salt, that is NaCl. So we'll see that all the acid later on, according to the Bronsted-Lowry definition, I'll be showing you that all the acid, they lose their hydrogen ion, they donate the hydrogen ion in order to form a salt. तो सॉल्ट बनाने के लिए वो हमेशा हाइड्रोजन आयन को सब्स्टिट्यूट करते हैं, रिप्लेस करते हैं किसी भी metal ion say in order to form salt. So this is the second definition. The second definition says that the acids are basically the proton donor. जो आपके एसिड्स जो होते हैं वो प्रोटॉन डोनर होते हैं, वो प्रोटॉन को डोनेट करते हैं. दैट मींस दे लूजेस H पॉजिटिव आयन, दे डोनेट. ठीक है. अच्छा, ये डेफिनेशन इसलिए है क्योंकि पहली डेफिनेशन हमने कहा था, पहली डेफिनेशन जो थी वो ये थी कि हमने ये स्टडी किया था कि H positive ion are basically H positive ions in an aqueous solution. H positive ion in an aqueous solution it tends to behave like an acid. But आगे जाके they have seen that the hydrochloric gas, hydrogen chloride gas, sorry, just a minute. So this definition came when the scientists saw that the gas, ठीक है, हम कहते हैं H positive and aqueous form, तो हाइड्रोजन क्लोराइड गैस, ठीक है, गैसेस फॉर्म में भी, जरूरी नहीं कि वाटर में हो, इट कंबाइंड विद अमोनिया गैस. ठीक है, तो दोनों गैसेस हैं, ये अल्कलाइन नेचर और ये एसिडिक नेचर, द बोथ आर नॉट डिसॉल्व्ड इन वाटर but they were forming a salt which was known as ammonium chloride. So when such things, such reaction took place, so they made them think, okay, how come they are gases, they are not dissolved in water, but still they are giving you salt. So they came up with the second definition of an acid, and it says that the acids are those which are proton donors. So in this scenario, the proton, which is H positive, is basically given away. It's been given away, right? It's combined with ammonia. ये दोनों आपस में combine, donate करके, they will be forming a compound which is a salt, which is NH4Cl. You'll be doing such examples in your A levels if you'll take A levels chemistry, right? So that is the reason, the second definition of acid that arrives. So once we have done both the definition of an acid, the first definition was they give hydrogen ion in aqueous solution, and the second definition was they are proton donors. So they can ask you any one of the equation. Bronsted-Lowry is where they act as a proton donor. Now let's talk about the type of acids, the categories of the acid. So the first category is on the basis of the strength of an acid. Okay, on the basis of the strength of an acid, we have two categories. We call them, we have a strong acid and we have weak acids, right? As I told you, strong acids are highly corrosive, as when they fall on our skin or on a hand or on the clothes, they are highly corrosive. The examples of the strong acids are hydrochloric acid, sulfuric acid, nitric acid. These are basically your strong acids. And the examples of your weak acids, they are present in your foodstuff. They are basically your organic acid. You can eat them as well. Okay, they are organic acid. All the organic acids are considered as a weak acid. Now, what makes the acid stronger and what makes the acid weaker? We already know that. I have emphasized on that the acids are the ones which give you H positive ion in an aqueous solution. So the acid which is going to give you maximum hydrogen ion in water is going to be considered as strong acid, right? And which will be giving you maximum, right? They'll be strong acid. And those will be who will be giving you few H positive aqueous ions, they will be known as your weak acid. So basically here we are talking about the first category, which is on the basis of strength. So either they are strong acid or weak acid, and that depends on the amount of hydrogen ions that particular is going to give. Okay, is this much clear? Now we know that when we add HCl in water, because this is going to ionize, it's going to split up, it's going to give you H positive ion, they dissociate into H positive ion and they'll be giving you chloride ion. Okay, so any acid when you dissolve it in water, so they basically split up, they get ionized, they give you ions, and they will be splitting up as H positive ion and into Cl ions. अगर ये आयनाइजेशन जो है वो कंप्लीट है, राइट? और आयनाइजेशन वाटर में अगर फॉर एग्जांपल इफ वी हैव, लेट्स से इफ वी हैव 100 molecule of an acid, if we have 100 molecule of an acid, and on when you add them to water, they will be giving you 100 ion of hydrogen ion and they give you 100 ion of chloride ion. That means उनकी आयनाइजेशन जो है वो कंप्लीट है. ठीक है, अगर कंप्लीट आयनाइजेशन हो रही है जिन एसिड्स के अंदर भी, दे आर बेसिकली नोन एज strong acids, right? So acids, they do dissociate. Acid, when you add them to water, they dissociate into their ions. When you dissolve them in water, they dissociate into ions. If you're getting maximum ions, then they are basically known as strong acids, right? Now comes a scenario where there are chances ke agar if you have 100 molecules of an acid, 100 molecule of an acid, and they do not give you, they give you only few, they give you only few hydrogen ion and in aqueous solution, then what is the reason for that? The reason for that is that those acids basically, now we are taking the example of carbonic acid here, and carbonic acid is considered as a weak acid. Carbonic acid is considered as a weak acid. So what happens here in the case of a carbonic acid, they will undergo, they will be ionizing into, the carbonic acid will be ionizing into H positive H positive aqueous and into the carbonate ion. But then what is going wrong? अगर वो ionize हो रहा है तो फिर क्या हो रहा है? फिर क्यों वो few hydrogen ions दे रहा है? The reason is that when it dissociates into hydrogen ion and carbonate ions, then what happens? These hydrogen and carbonate ions, they again combines to give you, they combines to give you back the molecule. So basically here what happens, this undergoes a reversible reaction. So it's going in the forward direction and it's going in the backward direction as well. So definitely when you have so when you have the 100 molecules of carbonic acid, they will split up, they will dissociate, they will break down into the ions. But these ions, they will break down into ions, but these ions will combine back, they will combine back to give you the molecule back again here. So it's a to and fro scenario. So at one particular point, in a beaker, if you have a beaker, so in a beaker you will be having carbonic acid molecules as well, you'll be having H positive aqueous molecule as well, and you will be having carbonate molecule as well. Because what is happening, the reaction is undergoing a you'll be have it is going a reversible, okay, it's a reversible reaction and it is going back and forth both. तो आपको किसी भी पॉइंट पर हाइड्रोजन आयन की मैक्सिमम कॉन्सेंट्रेशन नहीं मिलेगी, ठीक है. So we say that the weak acids are those acids which get partially ionized, partially ionized क्यों होते हैं? They get partially ionized. The reason for getting partially ionized is they undergo a reversible reaction. Because they undergo a reversible reaction, and that makes them a weak acid. Is that clear? So this is the reason. So all the organic acids, all the weak acid come under this category. Why? Because they get partially ionized. They do not completely ionize. Okay? Because they undergo the reversible reaction here. So that is the reason that we have the strong acids and we have weak acids. So the reason for having a strong acids and a weak acids is basically they give you maximum hydrogen ion concentration, maximum hydrogen ion concentration as they they are they are fully ionized. Okay, they are fully ionized, right? They completely dissociate, right? Another terminology we can say, they completely dissociates. The reverse of this is strong acid. Reverse of this, we will say do not give you maximum hydrogen ion concentration, as they get partially ionized, right? Or they incompletely dissociate. Right? Is this much clear? So this is how they often ask you the question that what are strong acids and what are weak acids. So you can say they are the one which completely dissociate, giving us maximum hydrogen ion concentration, or you can write down if weak acid, they incompletely dissociate, not giving you the maximum hydrogen ion concentration, or you can say partially ionized and fully ionized. So these two terminologies can be used to define the strong or weak acids, right? This is the slide of what I've explained right now, the difference between the strong and weak acids. In a solution hydrochloric acid, all the molecules of hydrogen chloride have become ionized. When you dissolve this in water, they 100% ionizes. Okay? They break down into the ions. They give you 100 ions of hydrogen and 100 of chloride. And you can see that the reaction is only going in the forward direction. It's only going in the forward direction. So definitely it's not reversing back. So when it is not reversing back, you're getting maximum hydrogen ion concentration. Now, but when you talk about the weak acids, some of the molecule have become ionized. We can say some. Why some? Basically, they are undergoing a reversible reaction. So when you have the ethanoic acid, so ethanoic acid will be breaking down into the ions. Let's say they will be breaking in order, if you have 100 molecules of this, they'll be breaking down. But then what happens, as soon as they break down, they combine to give you the ethanoic acid back again. So that is the reason we say that when you have a beaker of the ethanoic acid, you will be having the molecule of an acid, you will be having H positive ions, you will be having the other anion present. Let's say they have ethanoate ion present in them. So you will find the molecules, you'll find the H positive, and you will find the anion part of an acid. So that is they get partially ionized because they're undergoing a reversible reaction. Okay, they are dissociating, but they are undergoing a reversible reaction for the reason we say they are partially ionized. They are partially dissociated or partially ionized. Is it clear? So this is what I explained previously as well. Moving ahead, let's talk about the second category of the acids. So second category is on the basis of the dilution. So when you dilute, when you dissolve in water, so what is being formed? So when you dilute, you have got whenever any solution is being formed, the solution is made up of two parts. It's made up of a solute and it is made up of a solvent. Solute is something which is being dissolved in a solvent, right? So basically, if we have an acid, so acid is in the solution form. If we say HCl in aqueous, so I'm having HCl and aqueous. So HCl is basically my solute, right? Which is being dissolved in the solvent, which is my water. So depending on how much solute I'm having, right? How much solute I'm taking in order to dissolve in certain amount of water, defines the dilution, right? So on the basis of dilution, we have got dilute acids, and we have concentrated acid. So just keep it very clear over here कि आपके जो strong acids और जो weak acids होते हैं वो depend करता है कि कितना आप उनको water में dissolve कर रहे हैं. अगर आप थोड़ा सा solute ले रहे हैं और let's say 1 dm cube of water में या 1 liter of water में dissolve कर रहे हैं, तो they will be considered as dilute क्योंकि आपकी solute की quantity जो है, the solute quantity is less. But if the solute quantity is good enough, ठीक है, तो उसके अंदर अगर आप solute की quantity बहुत अच्छी ले रहे हैं और same amount of water में dissolve कर रहे हैं, then the acid is said to be concentrated, right? तो आपके पास weak and strong acids, they both can be dilute and concentrated, right? Depending on the amount of solute or amount of acid you're dissolving in the water. Is that clear? So there comes your second category. Coming to the third category, before I move on to the third category, let me just show you the pictorial representation of dilute and concentrated. Now here, this is a concentrated sugar solution, right? And this is, they're saying increasing the concentration of dilute sugar solution by adding concentrated. So you have few particles, few amount of sugar solute over here in this particular water. When you're adding more, so what is happened here is there are more sugar molecules present here. So this is making a concentrated. Concentrated is the one where you have more quantity of solute, and the dilute is the one, this is a dilute one, where you have a less molecules of solute. Okay, less molecules of solute, right? Moving on to the third category now. The third category depends on the basis, it's on the basis of the origin of an acid, right? So we have the mineral acids, and we have the organic acids. So organic acids are basically originated from the food stuff, okay? They originate from the natural stuff, natural, you can say food stuff or natural stuff. They are not basically manufactured in the industry, right? So those assets are basically known as organic assets. But the mineral assets, you have to manufacture them, right? You have to prepare them either in the lab or large scale manufacturing करनी है, तो वो आपके mineral assets कहलाते हैं. So on the basis of the origin, you can name them as a mineral asset, and you can name them as organic assets, right? So that's all about the introduction of an asset. In the next video, I'll be talking about I'll be talking about the chemical and the physical properties of an asset.